It's finally here. So this is the Twisted Builds Canbus logger. I'm finally going to start stocking and selling these. So I've been testing this one, or I've been testing mine. Mine's printed different colors, so I know which one's mine and which ones are stock units. But I've been testing mine for a little over a year now, working with Canbus logging factory cars, aftermarket engine management systems, scan tool behavior, stuff like that. So I wanted to go over in this video what you get with the Twisted Builds Canbus logger. First, we'll start with the logger itself. The logger is in a 3D printed case. It has a USB plug and an SD card plug, or SD card slot, I should say, and a push button. The push button is for SD card logging. So this has a 12-volt power input, then CAN bus and FD CAN. It has multiple switches in the front, and I will go over this. The controller itself will come with alligator clips. If you are doing tethered logging, which I'll be honest with you, most of the logging I have done with my unit has been tethered with a USB cord to my laptop. I actually enjoy doing it that way. However, I figured people may want to put this in a vehicle, a race car, whatever, give it power and ground, and do untethered logging. Log to the SD card, take the SD card out, toss it in your computer, and get a read. So that is a possibility. In the kit, as I said, you get the Canbus logger, you get the alligator clips, one per port, you get a USB cord, and you get a 16 gig SD card and an SD card adapter. Also, you get a color printed instruction manual. So the instruction manual is also going to be available on my website, where you can download it as well to have a digital copy, or if you need to print spares, or just go over it in the future for different settings. And I go over, let me bring that back, I go over everything in this instruction manual. And again, I'll be going over some of this stuff in the video. Apparently doing this one hand is not the best thing, but I go over the connection diagram and what does what. These switches, which I'll go over in this video, switches and information on the switches, and then also software instructions where you can get the software, which I will leave a link in the description below for the software and for where you can buy this logger, and it goes over all the settings you can do, so on and so forth. So yeah, so that's that. What I'm going to do is I'm going to hook up my logger, because I'm keeping I test all the customer units before they go out, but I keep them fresh and new. So I'm going to use my logger for the rest of this video to describe how this works and all the cool things you can do with the Twisted Builds Canbus logger. Now I've got my computer, or my Canbus logger, connected to my engine computer. This is actually a junkyard Ford Fiesta engine computer from a 2012 Ford Fiesta. It is connected to my Twisted Builds engine sim, which is simulating the engine computer. That way I can log the Canbus network off of it. So if you haven't already seen, the engine sim is already on my website for sale. You can go there and order one today. And you can see this is how I'm using it for this specific example for my Canbus logger. I am going to make another video about all the cool things you can do if that engine sim is in the works for the next week or two. It's going to happen. But back to the Canbus logger. So when you purchase your Canbus logger, as you saw, you get a Canbus logger, which is a black case. You get the leads, and you get a USB cord and an SD card. Mine, I don't even have the SD card in it. I don't use the tethered logging, or the SD card logging. For most of the time, it's there. I'm sure there's going to be instances where customers want it. I'm sure there's going to be instances in the future I want it. However, right now, I don't want it. So, I have it connected to my USB cord to my top. And I have my switches set up. So, switches on it are labeled 1 through 8. Switch 1 is Canbus 1. Okay, switch 1 through 6 are switches for 120 ohm resistors. They are physical hardware switches instead of software switches. So because most PCMs in modern vehicles have a terminating resistor in them, which is a 120 ohm resistor. You have to have terminating resistors at both ends of the network. I built this for doing this kind of stuff on the bench or in vehicle. So stuff when you're on the bench, like I have a module that has 120 ohm. I need to add 120 ohm to complete the network. I can flip switch 1 up because it's connected currently to Canbus 1 input, and that will give me a complete 60 ohm network on the bench. That way my logging is correct. I've got Canbus 1, 2, and 3. Or sorry, Canbus 1, Canbus 2, and Canbus FD, which is switches 1, 2, and 3. 4, 5, and 6 are the same thing repeated. So switch 4 is Canbus 1, 120 ohm. Switch 2 is switch 5 is Canbus 2, 120 ohm. Switch 6 is Canbus FD, 120 ohm. And some people are going to ask, why did you do 2 sets of 120 ohm resistors here? That is because there's going to be times where I or my customers are going to want to hook a module on a bench, possibly simulate it with a Twisted Builds engine sim, or just figure out, like, power it up on a bench and figure out what is getting broadcasted with the module just turned on. You need a complete network. The PCMs and like a lot of the newer ones or gateway modules have the resistors in them. But say for instance, I had a GM, actually I'm gonna grab it here, a GM T42, okay, module. This does not have a Canbus terminating network resistor in it. I could turn on both switches here to give it 60 ohms resistance, have this plugged into my engine sim, and output a VSS from it, which I've been working on. And it will, the Canbus logger will terminate the network, and this will talk to this. I can record, do all the things. So you'll run into modules that don't have terminating resistors in there. I made this logger so that way it doesn't matter. It's all nice and clean. You're not having to deal with resistors on the bench or anything like that. And it just flat out works. So to get the software, as I said, the software link is going to be in the description below. It is also going to be on the for sale ad page for the Canbus logger, and I do plan on writing a how-to tutorial a little bit, but this video tutorial is going to cover most of what you will run into with using the Twisted Builds Canbus logger. But the link is going to take you here to the GitHub where the 3 are listed. The software for this is cross-platform compatible. You have to use a laptop. You may be able to use a tablet. I have not tested it on like a Windows tablet or a Linux tablet or anything, or like a Mac tablet. But I have tested it on laptop computers. I've tested it with all 3, Windows, Linux, and I've had friends test it on their Macs. So all 3 download links are here: Windows, Mac, and Linux. You just grab the zip file and download the zip. And I'm going to show you how I do it here. So just download the zip file. It'll download to the downloads folder. Once that is done, drag or go into your downloads folder and double click the zip file. It'll bring you right here to the main file. I normally drag and drop that into my documents folder. You can drag and drop wherever you would like it, but I normally put mine in the documents folder. And I will show you what happens after that. So once it's in your downloads folder, it's going to look like this right here. So this right here, the Canbus Logger V2 EXE, is the actual program. I have on mine, I have send to a desktop create shortcut, and that creates a shortcut on the desktop with the Canbus Logger right there. So I actually have one up here. That's the same thing. You can take, like you can see how it says shortcut, the DXC. You can rename it if you want, or you can just leave it. So we can just literally do this. V2, went too far, and okay. And that is the same as that. And I'll just go into here and show you what it looks like. It may come up, Windows protected your PC, more info, click run. The reason it's doing this is I am not a verified publisher of software. Twisted Builds isn't either. I haven't paid for the Microsoft licensing to do it. It is safe software. I've written it myself. And I'm going to run this anyway on my own computer just to show you. It's fine. So this is the Canbus Logger 2.0. First, we're going to hit connect whenever you are connected to the unit. So again, USB cord to your computer. This isn't even powered up yet, but we're going to connect to the unit. So clicking that brings this dialog box up, and the software automatically looks for the logger. So as long as the logger is connected, it is going to pull all of the COM ports. If you're on Linux, it's the TTLY ports. I'm not quite sure on Mac what they call the ports, but same thing. It's gonna check all of the devices connected to the unit or the computer and look for the Canbus logger. So it automatically found it on COM 13. So we're gonna hit connect, and it will connect right up. If it has any kind of errors, it'll error message right here. Then we'll hit test. This makes sure that we're actually getting messages or able to talk to the logger. So we'll hit test, and it'll come up Twisted Builds LLC Canbus logger, firmware version, and the copyright. I actually finished the code on this last year. I've been testing it thoroughly since then. So, but yeah, so that it comes up with the test. If it comes back with this is printing to that window, is not that right there is not saved in the software. So if you get that message, you are definitely connected to the Canbus logger. So we're going to click OK to save everything, and now it is connected because it switches the button to disconnect. So we're going to go in, and I'm actually going to power on my engine sim. And you can see that it's ready to go. Those were lit up for a little bit. This is still not, like you can see, it was lighting up there a little bit. This is still a factory computer. It's not happy that it's not in a car, but for this test, it's going to work great. So we're going to go in. This device has multiple features. Obviously, connection settings brings up the same window we were in. We are going to go in and look at, we have auto baud, manual baud, and message display. So we're going to first go into manual baud. This is going to be a little out of order, but it's going to explain what's going on. So manual baud settings is going to bring up the current baud rates that are in the logger, that are saved into memory on the logger. I save these in the memory because of SD card logging. If you want to SD card log with the controller, you have to connect it to the computer first and preset everything before you ship the logger off in a car, your own car, whatever, or vehicle or whatever, right? Whatever you're Canbus logging. So, as I said, this right here is typed from the device itself. It prints it to the screen. None of this is saved in the software itself. So right now, CAN 1 and 2 are set to, this is bytes per second. So we normally talk in kilobytes per second. However, I wanted the end user to have pure flexibility, which means if you are using this logger on a proprietary Canbus network, say for instance the people who made the Canbus network picked a really oddball baud rate, you can set this down to the byte per second baud rate speed. So like you could use, say, an oscilloscope on the network, figure out what the baud rate speed is, set this right down to it, and you're good to go. So and then you can log with the nice fast logging speed that this has. So as I said, the baud rates at 10, it'd be 100,000 or 100 kps, right, on both, and then I've got set to 502 2 megabytes, so 500 kps and 200 megabyte per second for FD. We're not going to go into FD on this video. I will talk a little bit about it, but we're not going to go into that. So these are the manual baud rates, and as I said, if you want to change it to whatever, we'll say 125. So say 125 KB or kilobyte, so it's 125, and you add 3 zeros behind it. That's 125 KB or 125,000 baud per second or bit per second, right? So, and all you gotta do is if you want to send this to the controllers, you hit send CAN 1. And this is, again, the controller responding back that the CAN 1 is now set to 125 kbs. So if we want the current settings, you click current settings, and you can see the controller again told the software that we're at 125, I forgot this is a touchscreen, but 125 bytes per second, okay? So this is going to be fine because we're actually going to Autobaud this. I know from prior testing what this speed is. However, say for instance, you're connecting something that is standardized, like automotive or industrial, that runs on the standard Bosch speeds. It's not specialized. It's not super proprietary, whatever, right? Standard Bosch speeds, standard automotive speeds that you don't know what the baud rate is. You don't want to get the oscilloscope out, okay? You want to figure it out. So again, connect this to your Canbus network, okay? We're going to get out of the manual baud and we're going to go into Autobaud. So we go again here to File and Autobaud, okay? So I highly recommend, if you're going into automotive or industrial to log a Canbus network and you do not know what speed you're working with, highly recommend, without having anything connected to this, set this controller up manually for manual baud and then connect it up. Set it for like 100 kps or 100,000 bytes per second, something that you know is wrong. Then connect it up, disconnect the USB power to it, connect it to the network, connect it back to your computer, and then connect it to the software and bring up Autobaud. So right now I'm wired into CAN 1. We're going to bring up the CAN 1 and we're going to Autobaud test this. So we're testing at 125, 250, 500, and we found it. CAN 1 baud rate detected to be at 5,000 bytes, 500,000 bytes per second, or 500 kilobytes per second, right? So, which I knew, I'm on the high-speed CAN network. I knew that's what this was going to be. However, I wanted to show you guys how it works. It went, as I said, we had it set to 125 kbps or 125 kilobytes per second. Or actually, it might have been 100. I don't remember. Go back in the video. Regardless, and that will go through like that. It'll do the same for CAN 1, CAN 2, and CAN FD. So like that is CAN 1. CAN 2 is not even connected, right? So we're gonna go CAN 2, and it's going to error. But I'm gonna show you what it looks like when it errors out. So it's gonna go through all the rates. It's gonna go all the way up to 1,000, and then it's gonna error. Baud rate detection failed on CAN 2 because that's not connected to anything. If it's arbitrated rate or if the wiring's not correct, it'll error out as well. CAN FD is the same way. I'm not going to go into CAN FD. That takes longer, definitely when you're not connected to anything, because of all the different rates that it could be. So we're going to click OK here because we found it. So next I'm going to go into all of the, first off, the message display, and then I'll go into the tabs. Okay, so now we're going to go into File, and we're going to show you message display settings. So this, actually go into the message settings first. So this controller can save the data, and it saves data in a CSV file, and it can save the data in hex format or decimal format. I first started doing Canbus stuff in decimal, and I still sometimes prefer the data in decimal. Sometimes I prefer in hex. It depends on what exactly I'm either reverse engineering or doing in general, or recording, so on and so forth, right? I don't want to be forcing you to do it one way or the other. I want you to have the options of having it in either decimal or hex. So this is where you go. So right now, the controllers, normally for most of my work as of late, I've been doing the message IDs in hex, the length in decimal. The only time having that in hex changes is really when you're working with FD networks, when you can have 64 byte data payloads instead of like your normal 8 you're gonna see like today. And then the data output is big. So you can have the data output in hex, or you can have the data output in decimal. The second you change a drop down, it automatically sends to the device, or sends the information to the device. So like right now, if I hit current settings, it is hex, decimal. So I like to view the message data in hex. So there's that. We actually, for this demonstration, I might do it in decimal. May be easier to understand what's going on. We're going to leave the message ID in hex. But this is how you change that, okay? So if you want to switch the message IDs from hex to decimal and have it save in the CSV file or be viewable in this is where you go. And then if you want to get the current settings, just click current. The next very important tab under message display is the Canbus mode. Right now, this controller is in normal Canbus mode because this is the only module on the network except for this. To explain, I've got normal and I've got listen only, okay? So normal mode on the data protocol layer is what and again, correct me if I'm wrong in the comments, this is how I understand it. At the data protocol level, like the stuff you're not going to see with the software, stuff you're not going to see with logging, when this sends a Canbus message to this guy, this sends back an acknowledgement bit to this, letting it know the message got here okay. So, with this being the only thing on the network currently, which means also no scan tool devices, nothing else. This is literally the only thing. This and this are the only two on the network. I have to have this set up in normal mode for this to talk, or this literally does nothing on the Canbus network at all. It does not respond. You could do the Baud test with this. It doesn't work. Like, it has to be in normal mode in this configuration. Now, with that said, say for instance you want to log, we're going to pick on a factory scan tool. You have this device in line with the OBD2 port. So they make OBD2 breakouts. I actually use one. And you put this device onto like pin 6 and 14 for the OBD2 data network or diag network or whatever, or have it on diag 1 and 2 for the newer stuff, so on and so forth, right? But you don't want the vehicle or the scan tool device to know that you're logging with this, okay? You don't want anyone to know. Don't want anyone to respond differently, okay? You put this in listen only mode, and then you send the setting, and this changes the controller to listen only Canbus mode. At that point, nothing has any idea that this logger is attached to it at all. So you can go on and record and do all your things, all your recordings you want, everything. If you're on a vehicle, if you are logging in between a scanner and the OBD2 port or whatever, you don't want any module acting any differently because you don't want them to know you're there. You put this in listen only mode, hook this up, and you go. None of the wiser. No one has any idea. But again, for bench situations, definitely like what we're doing right now, I have to put the logger into normal mode so this actually sees it's talking to something. It doesn't know what it's talking to because this doesn't resend any data back except that one little acknowledgement like, hey, I got the data. So I'm going to flip this back to the normal mode, and we're going to send that over. Okay. Normal Canbus mode, and that is that. So again, very important tab. It's under the message display settings. Just tab over for the Canbus mode, and we're going to click OK. Next, I'm going to show you the data coming in. So we are connected. I am simulating RPM input into this, so it actually thinks the engine is running. This is technically in theft because it doesn't have any of the PATS stuff or the anti-theft. This is like an untouched junkyard module. So it's powered up. It's getting a cam and crank signal input from my engine sim. That's also why you see pulse width 1 and 2. That's actually my ignition coils ever so slightly come on and off, on and off. It's because this is currently thinking it's getting stolen. I didn't steal it. I got the engine computer from a junkyard. Just being real with you guys, that's what's going on there. But for this, we're going to be able to get the RPM data. And to also be forthright with you all, I haven't even tried this yet on this computer. I just wired this up a while ago. I haven't even done the reverse engineering yet to get data off of it. We're all going to see together. That way you can see how easy it is to use this. I have specifically been waiting to do this with this engine computer until I was right here recording all this with you. So, going back to the main usage, you have everything hooked up. You got your toggle or your slide switches set up for your resistors you need. You've got the software and the controller set up. You're ready to go. You've auto bought or manual bought it. You know you're getting your messages in. The View All tab. All these tabs are kind of self-explanatory, okay? So View All means it's going to view CAN 1, CAN 2, and CAN FD in receive order. Okay, it's going to view all the messages coming into this. That works great for like modern, trying to figure out modern gateway modules. If you want to record 3 different networks, CAN FD, and then like, or one of the CAN FDs. I know the really new stuff's, we're getting into a lot of FD networks. If you want to record one CAN FD network and then the 2 others to see if the gateway module or, you know, whatever module's acting like a gateway module, is changing the data on you between one network to the other, you can use this and receive everything in chronological order as it was seen by the logger. Okay, that's the View All tab, and I'm actually going to start it, and you will see it is literally just going to scroll. But this is all, I'll stop it quick, but this is all of the data coming in. And again, I switched this to decimal, so all this is decimal data coming into the controller. If we scroll up all the way to the top, we will see the controller. This is pretty much just a text box that the controller is filling out. It fills everything out for like, if you're going to review it in a spreadsheet editor, which I will again show you on this video. So again, View All tab, right? This views everything. You have the clear log and the save log buttons down here on all 3. So like FD's got them. Yeah, if I can mouse over and do it. CAN 1 and CAN 2 have them too, okay? So we're going to go back to View All. I'm going to clear all this, okay? So we're going to clear the log, and that just clears everything. You start over. Now we're going to start and view all again, and we're going to record everything. We're going to stop it, and I'm going to save the log. Now again, I wasn't modifying with RPM or anything, so we're going to save the log, and it will bring up the save dialog. And you can save it wherever you want to save it. So I'm going to just save it to my desktop. We're going to do video log 1. Perfect. And there we go. I should have thought about that before I made the video. But anyway, video log 1. Okay. So we can clear that log, and it'll do that. You don't have to clear the log. You can tab over if you want. But say, for instance, you have this connected to 3 networks, but you only want to record the data off of one of the 3. You don't have to unplug anything or anything like that. You just go over to the tab you want. Right now we're connected to CAN 1. Hit start, and it will record the data on CAN 1. So while we're doing this, I'm actually going to increase the RPM on purpose. Okay? And then we're going to decrease it back down. I don't know what RPM I'm doing without having my scanner hooked up to this. I know it's getting RPM data into it. I did check. But regardless, so we just did that. We did a whole bunch of log, right? We're going to stop it. We're going to save the log. And I'm going to save it as video log. Like you can see, it was saved as a CSV file. I'm going to do video log 2. RPM sweep. Okay. So we're going to hit save. Perfect. So that is how you record all the data coming in. Either View All, CAN FD All, CAN 1, or CAN 2. And again, it's CAN 1 network, CAN 2 network, CAN FD network, or all of the networks coming into the logger, right? All right, so next we're going to show you the CAN message ID viewer. This right here, I'm actually going to make this full screen. See if I can get all. It's not going to show all of them at one time, but you're going to see we don't really need to know the time off the top. So you can select the network you're connected to, CAN 1, CAN 2, or CAN FD. This does not do all 3. This is normally like you want to verify, you used the log to verify a certain message you want to monitor while you're messing with things, either on car or on bench. We're going to do CAN 1 because that's what I'm connected to, right? We're going to find IDs. What this is going to do is it's going to find all the message IDs currently coming into the logger. And it's on an automatic timer. So we're going to hit find IDs, and we're going to wait for that to finish, okay? So it takes, I believe I have it set up for 30 seconds, which feels like forever. whenever you click it, and see how it switched to find IDs. It's done. So you can go down the drop down menu, and these are all of the IDs, and again in hex, that are currently coming into the unit. Right, so we're gonna start with 200. I know this is a Ford module, they're kind of standardized, so we're gonna go 200. I'm just gonna hit start. You can see the timer, again, touchscreen. You can see the timer increasing. The timer increasing is the timer printed by this. So when that's increasing, it's not the software. It's actually this saying, hey, this is the last time I got this message. And it doesn't look like anything. Well, it's got a rolling counter of some sort. You can see these right here are changing. They even may be temperature or something. Let me fiddle with temp. See if I can get it to, nope, RPM maybe? There we go. We got RPM input. Look at that. I'm guessing that's RPM input. So again, I haven't actually figured this one out, but you can see how these numbers are changing by me literally changing the RPM on the logger. So this could be like torque request. It could be a number of different things. The video of me using this logger and showing you what you're getting when you purchase a Twisted Builds LLC logger is not going to go into reverse engineering the networks, okay? Again, you can grab whatever ID you want. Say we're going to go to 360, and you can see it's incrementing, so we're getting messages in, and it looks like nothing is really coming in. We're getting a 255 byte, which again, this would be FF if this was set up in hex, but just for the sake of the video, we're doing everything in decimal. We're going to see if I get any rolling. So you can see that's a rolling counter, right? How that's going up. And that's why this is kind of nice, is because you can click a specific ID, go to it while you're connected live, and you can fiddle with things. Like if this was in a car, you could press the throttle up and down and figure out what byte in that message, what message ID, and what byte you're working with is the message you're looking for, right? So we can see like this is a rolling counter, and it's going up to 255, I believe, and then stopping, or roughly there. And this in the log, this is real time. So you can see it's not like this message doesn't go across the bus super fast. And because of that, it's also filtering out all the messages it's receiving. So this isn't as accurate as the log. The log is super, super accurate. So I would say 95% of my reverse engineering with Canbus stuff, of my Twisted Builds Canbus logger, is using the CSV log. So I'm actually just going to stop this right now, because that is actually most of the software. I will show you the CSV log in a second. Two things we haven't gone over is underneath the help tab right here, you're going to see about us, which just brings up a generic, this is about the software, and then the usage instructions, which also kind of go over what I talked to you about in this video. Just, hey, this is the how to connect to it, the auto baud, manual baud, message display, first tab, view all, second tab, CanFD. Just kind of goes over everything I already talked about in this video, okay? So, but yeah, so that is the software and how you use it. As I said, most of my stuff I'll either view all or like can one. So like if I view all, I'll just start the log now, and like you can start the log, and I already saved the log of me fiddling with the RPM. We're gonna stop this log, and you'll see that like the other logs stay there. So like you can see the timer change, like 34 versus 28. That way, if you forget, like sometimes I forget to save the log and I'll go over and have a heart attack moment, I set the software up that way. If you forget to like save this log before you switch tabs to log something else, the log is still there as long as you didn't clear the log out, so you can save the log. View all is the same way. Like all the view all tabs, or all the can tabs are the same way. And then message ID, you're not saving in the data come in, you're just viewing it live while it's coming into the logger. So next we're going to bring up the second log, because it has an RPM sweep instead of me just showing you how the logs work. And we're going to go after what could be the RPM, it could be torque request. Again, reverse engineering the Canbus messages themselves are going to be outside the scope of this specific video. I just want to show you what you are getting with your Canbus logger. Alright, so back to my desktop, because that's where I saved the log. We're going to bring up the log to RPM sweep, or video log 2. I'm probably going to butcher how to say this, LibreOffice. I was using Google Sheets. And Google Sheets is nice if you're working at multiple different computers. The problem is these Canbus logs can get very large, definitely on modern vehicles that are moving a lot of data around. Definitely on CanFD, the logs can get very large, and they only have text in them. So because of that, Google Sheets, if it even opens it at all, will normally like stall or freeze or lag or whatever, because it's web-based, right? So I use, as I said, I'm going to butcher the name, LibreOffice Calc, which is it's an open source, free-to-use spreadsheet program. I'll include a link to that in the description as well, and in the for sale thing, that you can grab your own version of that, download it, or your own copy of that, download it and install it. This also works with Microsoft Excel if you pay for that, like Excel 365 or whatever. As I said, I like to use the LibreOffice. It's open source, it's free to use. It works really well for what I'm going to show you. So when you open it up, this logger saves everything in CSV files. When you open it up, you're going to get the text import. I have never messed with this. It's always opened them up just fine. Literally just click OK, and it will go through, and it does take a second, and there you go. So I'm going to click X on this for right now. So the text at the very top of the view all or can one things I was talking about earlier is this right here, actually. So this is from can one. If it was view all, it would have time all the way through byte 63. So because this is can one and can 2 only can receive 8 bytes. It's 0 indexed, so it's bytes 0 through 7. Because those are for regular 2.0b networks. They're not for CanFD. CanFD can have a 64-byte payload. The regular cans you see in most automotive applications only have at a max 8 that they're using. So we're going to go into this a little bit. Time, this is not real world time. This is time that this has been turned on, okay? Now, to give you reference, and I have this in the software as well, this is microseconds. So microseconds, for example, you have, most people know milliseconds. You have 1,000 milliseconds in a full second, right? So like, for instance, I'm a gearhead. If you look at a drag strip, like a quarter-mile time slip, right? Say you went 9,824, okay? That 824 after the decimal point is milliseconds. You went it took you 9 seconds and 824 milliseconds, right? Like say cover a quarter mile or something, okay? So every 1 millisecond, which is that third decimal over, right? So it'd be again 9.864 or whatever I said. We're gonna say 864, 9.864. That 4 is 4 milliseconds, okay? There's 1,000 microseconds in a millisecond. So that 4 would be 4,000 microseconds, okay? That's how fast I had to get this working to be real-time accurate with recording data and getting it from the modern CanFD networks in time order. This is why it took me a while to develop this and get this onto the market, is because of the sheer speed. The chips I'm using inside here, mainly the main brain of it, is way overkill for what I'm doing. However, I wanted way more power than I needed, so that way I could get everything in real-time order, because I've used other products for logging, and the buffer size or the buffer delay or whatever you call it is so slow it flat out misses Canbus frames. I know a lot of us who, if you are watching this, who do Canbus logging or Canbus reverse engineering work, or Canbus working like you're using a logger to verify what's going on is actually going on your network. I'm sure a lot of you have ran into this, where the network buffer or the time delay with the logger, just it would flat out miss things on the network, and it drove me insane with a couple of projects I was working on. That was the main reason I built this logger. So going back to the time thing, the first one right here is microseconds. The second one is milliseconds. Okay, so that's like 120, that's 38 microseconds, 122 milliseconds, 46 seconds, 27 minutes. Okay, which means this video is gonna be long. I apologize. So, but, and then it has hours. It goes up to obviously 24 hours. I don't expect anyone to log for more than 24 hours with this in standalone configuration. Most of your modern networks, unless it's going to sleep and waking, like if it's awake the entire time, the 16 gig flash drive is probably not big enough. B, the sheer amount of data would be insane. And I just don't expect anyone to be logging something for longer than 24 hours worth of data on this. That timer will roll over. It will still record. It's just going to roll over. So, regardless, going back to this, the network right here is the network that it received the message on. So, like right now, I'm only connected to one network. I have stress test this thing with like a modern 24 Super Duty with the new CanFD network. So it was on 2 high-speed CAN networks and CanFD while the engine was running. Stress tested this, and like it doesn't care. So, but again, CAN 1 is CAN 1 coming in, CAN 2 would be CAN 2 coming in, CanFD is CanFD coming in. That is that right there. Message ID. Again, this is in hex, and I will take this and normally like make them all, because the hex, the letters will kind of go over and it drives me insane. I'll move everything over so it's all even, right? I'll also normally, just for ease of going through the data, I will freeze the top row normally. So freeze first row. And what that will do is like you can scroll through all the data and the first row is not going to move. That way you know like where you're at in the data. So message ID is pretty self-explanatory. That is the message ID that the logger received and recorded. Extended ID is in I don't want to say this. This is in binary format, so 0 and 1. So 0 means the message ID was not extended. 1 means the message ID was extended. You'll see like your Holy Terminator X stuff uses extended message IDs, so all of these would be 1s. So, or most of them, right? Message length. This is handy because not all of your messages are 8 bytes long. I have ran into some manufacturers that decide like this specific ID only needs 3 bytes of data. This will tell you how many bytes are actually in the message, and then the message itself, okay? So as you can see, like we have a 200 here, then we have another 200 here. But you have a bunch of data in between there, right? So it kind of makes it hard to figure out what exactly you've got going on. Not to mention just to, let's see. So that little bit of time, we had, go up. We had 19,847 messages go across the network. Let's see, so that's 2812, and that's not even 2 full minutes. We had 19,000 messages go across a slower network. Okay, this is where I was getting at. The amount of data you can get into starts getting astronomically high. So I don't plan on, like, I don't think anyone's going to record for 24 hours, so on and so forth. Now, for going through the data, again, you're not going to want to go through 19,000 lines of data when you're looking for certain message IDs. So I will select all. The great thing, and like Excel does this too, right? You can ascend or do descending order, right? So we're going to do A to Z. So this is going to take the lowest one to the highest one, okay? So we're going to sort ascending, and we're going to hit extend selection, and you're going to go. And what it does is it will sort everything all the way over, and we can look for our RPM. Now, from the live message viewer, we know that message 200 had some sort of RPM data. Now that could have been torque requested, that may not have been actual engine RPM, but we're going to page down here and we're gonna see how this data is changing right here. That was me fiddling with the RPM knob. Okay. And you can actually see like how it goes right down to here and then higher, right? So again, this video, I'm not going to go over how to reverse engineer the messages to get valid data. And it may be easier to have the data in hex than it does in decimal. But most of us read in decimal because that's how we are, we grew up reading numbers, right? So I switched it to decimal for the sake of this video. If I was actually going to do this and try to figure out the RPM from this, which I do actually plan on doing in a YouTube video, just not this specific one, I would go in and probably have this data in hex and go through the data that way. But you can clearly see, like when I was filling with the RPM, everything here was changing. But again, it could have been torque request, it could have been engine RPM itself. You don't really know until you start digging in and reversing the data itself, right? But we know that was a change. Now, the great thing about having the engine sim or whatever is, like, if I wanted to go after, say for instance, I have coolant temperature, I have engine coolant temperature and air intake temperature sensors simmed on this. I also have barometric and map pressure and a couple others, right? If I wanted to go after a single message, like I'm going to change one value, right? Say it's engine coolant temp. I could start the log, change the engine coolant temp, just swing it back and forth. It doesn't have to be exact. We can do wide swings at first just to figure out what message ID it's on. I could do that, go through the data here, and figure out, like, oh, there, like, again, this was RPM, but you can see where the data changed, like, oh, that right there, for example, say it was engine coolant temperature, oh, like, that's it. That one we know was engine RPM. I didn't even go through the others. But let's go down, and you're going to see, I'm just literally holding page down, and we're going through, so we can get to the next one. And like, that is mainly rolling code. Yeah, it's not even, so. And again, it could be, like, you can see this right here is the 2, byte 0 is 2, and then we go up. So this actually may be 14, 19, 21, 22. This actually could be engine RPM data. 20 instead of 200, it could be 201. Again, multiple different messages changed during the recording, and this is where you would actually have to reverse it. And if I were to do this, where I actually needed the data, I plan on doing this in a YouTube video. I would also have a scan tool hooked up to my OBD2 port right here, which is wired to this, and data log, like, I hit this RPM and this RPM with my engine sim, and then I can go through the log and map it out either in hex or in decimal, right? And figure out, okay, so the log says I hit this RPM and this RPM after you do the math. And if it's like identical to what the scan tool is saying, you normally hit your value, okay? But that's how you kind of go through the data. That's purposely also why I waited to go over the data with you guys or gals interested in buying this Twisted Builds engine sim until I had this all hooked up for this video, so that way you could see, like, I already found, like, there was 2 messages, literally, like, it's the first 2 in the recording, like, for sure have some sort of RPM data in it. What exactly RPM data is in there, it's hard to say. I don't know exactly without actually going in and reversing it, but we found 2 message IDs that have data in it, and, like, literally I will page through and just go through all the data. Like, you can see, like, most of this doesn't change until it changes message IDs, and then it's a massive change. And then you can kind of go through and just, like, this one, like, this message literally for seconds didn't change at all. It's like, we know for a fact that that doesn't mean anything for RPM, at least. And you're logging multiple things for this, like, again, RPM, torque request, whatever else uses RPM data. But that is how the logger works. That is what you're getting with the Canbus logger. This one, again, is way overbuilt. It's got way more power than it needs, because I, again, was so tired of working with equipment that was missing frames, that was missing messages. I have thoroughly tested this with factory scan tool equipment. I've tested this with aftermarket scan tool equipment. I've tested this with a bench Terminator X, Mega Squirt, Micro Squirt, factory computers, factory TC, like the factory transmission control modules, I've done anything that has Canbus. I've tested this. I've tested this with my own cars. I've tested this with Holy Terminator X equipped vehicles, all kinds of things. It works great. That's why it also took forever for me to get this ready to go for market. But so as you can see, you get the software. It dumps everything in the CSV file. One thing I didn't talk about is the SD card log. You would put the SD card in here, and you will hit this button right here, and it will start the log. So like you can see the red light. The red light means it's logging. If it had an SD card in here, that would mean it's logging. And then I let off, and that's off. The LED is not tied to this switch. I want to be clear on that. The LED is tied to the microcontroller in here. So like just because you hit the switch doesn't mean it's actually logging. If there is something wrong with the, right now that light LED came on because I'm connected to a live computer. If there's something wrong, that LED will not light up whenever you press the toggle in, and that means it is not logging. I also, before you do a mission critical log where you absolutely need the data, I would test it first, which would be get the SD card in there, do a log, shut everything down, pull the SD card out, toss it into your computer, and look at the CSV log. The CSV log will look exactly like this one. It saves logs in numerical order, so it'll be like log 1, log 2, log 3, log 4. I would do that before you ship this out on a mission critical log to make sure that it is getting the data you need. And just, again, make sure it's working. It's always worked for everything I've tested it with. And again, 90% of what I do is on the bench tethered with a USB cord. It is the same speed USB for logging as it is for the SD card, and that is because of the way I coded this. Everything gets saved to the controller itself and then prints, because as if anyone computer knowledgeable watches this video, we all know the USB data, definitely over a USB 2.0, is not super fast. So what is going on is this is saving all the data to it and then going as fast as the computer will allow it to print. But it makes sure that everything gets saved to the log. It does not miss a frame. That was my whole reason for building this. And I did finally get through, and it works great. So, this is a very long video on how this works. I know that. If you've made it to the very end, thank you. And I will go over pricing at the very end. It's $200 shipped to your door in the United States. So, as you saw in the beginning of the video, you get the black cased logger with a USB cord and SD card with an SD card micro to regular SD card adapter to plug it into your computer to get the logs off of. So $200 shipped to your in the United States. I will ship this internationally, but you need to email sales@twistedbuilds.com. That's sales@twistedbuilds.com. Because getting anything out of the United States shipping wise, at least for me, has always been a little bit of an expenditure. I will get you quotes on what it's going to take to ship it to your door. I've shipped stuff all over so far, like Canada, Australia. I've shipped stuff to South America, I believe, Europe, stuff like that, right? So I will ship wherever, but you have to email me, sales@twistedbuilds.com, and we will do the transaction off the website. Anyone in the United States, just go to twistedbuilds.com. You can order, if this video is on the website, you can order yours. You're ready to go. If you made it to the end of this video, thank you so much for watching. I know this is a bit of a long-winded video, but I want to make sure you understand exactly what you're getting for your money. I love this thing. I use this thing. I want to use it more. Life's busy. I'm working on engine orders or engine sim orders. I'm working on bringing the boost controller to market, but I use this. Some of you guys and gals saw the Holy Terminator X to like the digital dash display. I used this on the Terminator X before the DBC was commercially available to get the RPM data and everything off of it to work with that Terminator X. Verify everything was the right data, and then use it in my Arduino code for the screen I was doing at the time. I still may fiddle with it. There's so many people that make screens now. I don't know if I'm going to be getting into that market. I'm going to kind of focus on the boost controller stuff. And there's other Canbus stuff. There's other Canbus stuff I want to work on. But my first thing was getting this ready to go, tested, and shipping. So as I said, $200 shipped to your door. And I guess if you have any questions, leave a comment and leave a like if you like this video. I know it's long-winded and I apologize, but again, I just wanted to make sure everyone knew exactly what they're getting and how to use the unit. So thank you, everyone, and have a good day. Bye.